In this video, I'm going to cover how to use the quadratic formula to solve quadratic equations. The first step is to make sure that our equations are written in standard form. ax squared plus bx plus c equals 0. So we need all the terms on one side of the equation equaling 0. So I'll start number 1 by adding 6x to both sides of the equation. This will give us 3x squared plus 6x plus 2 equals 0. Now we can identify a, b, and c, and those are the values that we will use to solve this equation. The quadratic formula involves the opposite of b, and 6 is b, plus or minus the square root of that same b value squared minus 4, and then we multiply a times c. A is 3 and c is 2. And all of this is divided by 2 times a. And again, a is 3. So we will next simplify under the square root, and we will get 36 minus 4 times 3 is 12 times 2 is 24. And again, all of this is over 2 times 3, or 6. Simplifying further, under the square root, we get square root of 12. Now you might recall that square root 12 is the same as square root 4 times square root 3, and since 4 is a perfect square, we can take the square root of 4, and that is 2. So square root 12 simplifies to 2 square root 3. I will substitute 2 square root 3 where the 12 was. Now there are a couple different methods of simplifying this fraction. One method is to realize that we have a factor of 2 in both terms in the numerator and the denominator. So we could actually divide all three of these terms by 2. Essentially what we are doing is factoring out of 2 by dividing both of these terms by 2 in the numerator, and then factoring out a 2 in the denominator, which actually brings it back to what it used to look like in the denominator. We could see that we have a factor of 2 that can cancel. So this leaves us with x equals negative 3 plus square root 3 divided by 3, and negative 3 minus square root 3 divided by 3. These are our two final answers. It might be tempting to want to cancel the 3's, but we can't cancel the 3's unless there's a common factor of 3 in every term in the numerator. The square root 3 is a square root 3, not a 3, so this is our final answer. For problem number 2, we already have this quadratic written in standard form, so we can easily identify a, b, and c. Next, I will substitute them into the quadratic formula. In the numerator, we have the opposite of b plus or minus square root of b squared minus 4 times a, which is 2, times c, which is 5, all over 2 times a, and a is 2. So again, we will start simplifying this fraction. The opposite of 3 is negative 3, plus or minus square root of 3 times 3 is 9, minus 4 times 2 to 8 is 40, all over 2 times 2, which of course is 4. Simplifying under the radical, we get negative 3 plus or minus negative 31 all over 4. Now 31 has no perfect square factors, so 31 cannot be broken down further. However, square root of negative 31 can be written as square root 31 times square root of negative 1. And the square root of negative 1 is defined to be the imaginary number I. That's what we want to do next, is make this substitution. So this is not our final answer. Our final answer will be found by substituting square root 31I into the numerator, all over 4. You might recall that answers involving imaginary numbers should always be written in the form a plus bi, where a and b are real and the imaginary number is written at the end of the second term. So we are going to separate this single fraction into 2 fractions so that I will be only on the second term. So our answers will be negative 3/4 plus square root 31 over 4i and negative 3/4 minus square root 31 over 4i. These are our 2 solutions. Let's try another one with an imaginary solution. For this third problem, you could try factoring, but it is not factorable. Therefore, I will solve this one again using the quadratic formula. A is 1, B is 6, and C is 10. Substituting these values into the formula, we get negative 6 plus or minus square root of 6 squared minus 4. A is 1, C is 10, all over 2 times A is 1. Simplifying, negative 6 is negative 6 plus or minus square root of 6 times 6 is 36 minus 4 times 1 times 10 is 40 all over 2. It looks like we're going to get another imaginary solution because under the radical we have a negative number, negative 4. Square root of negative 4 is the square root of 4 times the square root of negative 1. Since 4 is a perfect square, square root 4 we can simplify to be 2, and square root negative 1 is I. So we will substitute that at the top of the fraction. Negative 6 plus or minus 2i all over 2. 2 divides into 6, 2, and 2. So we can factor out a 2, leaving us with negative 3 plus or minus I in the numerator all over 2. The 2's will cancel, and we get our 2 solutions, negative 3 plus I and negative 3 minus I. I hope this video helps in understanding how the quadratic formula works. If you found this video helpful, please subscribe for more math tips.